Howdy and welcome to AP Calculus Test Review B. So these are the solutions. We're on page 88. We're going to work these problems, and then we had that additional review sheet. We're going to work those, numbers 1 through 6. And then I'm going to do a little 5-minute kind of conceptual review, 5 or 10 minutes, to help you understand how to study for the test. All right, so number 41, the instructions on 41 just determine the intervals on which the function is continuous. And again, just like test review A, really I want to know where's the function not continuous. So here we have f of x equals 3 over x plus 1. So it would be undefined at x equals -1. Can't cancel that out, so it's a non-removable discontinuity at x equals -1. That makes it, in this case, a vertical asymptote. All right, there's not a jump in the function, so that's a vertical asymptote. Number 42, f of x equals x plus 1 over 2x plus 2. We could factor a 2 out of the denominator, and then we'd have 2 times x plus 1. We can cancel the x plus 1 over x plus 1 as long as x does not equal -1. So that means we have a removable discontinuity at x equals -1. Okay, the instructions on 49 through 52 are to find any vertical asymptotes. So number 49, we have g of x is 1 plus 2 over x. So what number makes the denominator 0? That's just simply, don't overthink it. It's at x equals 0 there. All right, h of x, number 50, is 4x over 4 minus x squared. Just to check and see if anything cancels, we're going to factor the bottom into 2 minus x times 2 plus x, but nothing cancels. So what values make the denominator 0? It's going to be 2 and -2. So we have a vertical asymptote at plus or minus 2. 51, we have f of x is 8 over x minus 10, all squared. It's just asking us to find the vertical asymptote. We're not taking the limit as x approaches infinity or negative infinity here. Just so, what value of x? That would be 10, because if you plug in a 10, you're going to have a 0 on the bottom. Can't cancel anything out, so it is indeed a vertical asymptote at x equals 10. So just don't want to overthink these when it's asking for vertical asymptotes. 52, f of x is cosecant pi x. I'm going to change that to sine, since sine goes with cosecant. That would be 1 over sine pi x. Sine is 0 at 0, pi, 2 pi, 3 pi, okay? So we have a vertical asymptote at x equals 0, 1, 2, 3, etc. forever. So the way, and also in the negative direction. So the way that you could denote that is x is just equal to 0, start with that, and plus n, where n is an integer. All right, that does it for the book. Now let's go ahead and get out your additional review sheet. So we are looking at this right here. And the first question says, given the limit x approaches 3 is 2x minus 5, find delta greater than 0 such that the absolute value of f of x minus L is less than 0.01 whenever 0 is between the absolute value of x minus 3 less than delta. Okay, this is the epsilon delta definition of a limit. And so this was from our first homework set. So I didn't want you to forget how to do these. You will be responsible for this on the test, but it's not really too hard. So we need the form f of x minus L. We need to look at that less than 0.01. So f of x is 2x minus 5. Now the limit as x approaches 3, that's L, of 2x minus 5, that limit's 2 times 3, 6 minus 5 is 1. So minus 1, that's you take the limit of that function, so the absolute value of that, less than 0.01. So I've got the absolute value of 2x minus 6 is less than 0.01. Now I need the form x minus 3, absolute value of x minus 3. So I get that by dividing both sides by 2. So that would be less than 0.005. And that is your delta greater than 0. Okay. So number 2 is if the limit as x approaches c of f of x is 5 and the limit of as x approaches c of g of x is 3, find the limit of f of x times g of x. Well, all you have to do there is multiply the limit of f of x, which is 5, times the limit of g of x, which is 3, and that's 15. If it was divide, then you would divide the two. Okay, so definitely nothing special about that problem. Just don't make a silly mistake. All right, number 3. Now, we didn't have any trigonometric limit practice from the book, really, maybe only one problem, so I wanted to do several of these because there are several of these on the test. Okay, and remember I'm going to go ahead and erase 1 and 2 and go ahead and put our formulas up here. So that'd be the limit as x approaches 0 of sine x over x is equal to 1. The limit as x approaches 0 of x over sine x equal to 1. You do need to have these memorized. The limit as x approaches 0 of sine cx over cx is equal to 1. And then the reciprocal of that, cx over sine cx is equal to 1. And then the one that we have with cosine, the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. And you do need to know your other trig relationships as well, such as tangent x equals sine x over cosine x, etc. Cotangent x equals cosine x over sine x. You might need to know that sine squared x plus cosine squared x equals 1. I think we used that one. You know, and cosecant and secant, you know, those as well. So all of that, you know, cosecant equals 1 over sine. Secant equals 1 over cosine. Okay, so let's work number 3. Well, I'm going to need to break this up so that I can make it look like this right here and this right here. So the limit as x approaches 0 of sine 5x over 1 times 1 over sine 2x. Now, what do we need right here? We need a 5x. So I'm just going to put it in right there. What do I need right here on top? I need a 2x. So I'm just going to put it in. What have I multiplied now? 2x over 5x. I've multiplied by 2/5. So in order for this equation to not be invalid, I need to multiply the whole thing now by 5/2. So really all I did was multiply all of this by 1. Okay, so now I'm going to rewrite it as the limit as x approaches 0 of sine 5x over 5x times 2x over sine 2x times 5/2. That's all we did. And that's the exact same equation. Well, that's 1. That's 1. The limit of a constant is the constant, so that's 5/2. So the answer is 5/2. Beautiful. I love these. We are manipulating math to do our bidding here. All right. Number 4. We want to find the limit as t approaches 0 of tangent t over 2t. Well, first what I want to do is change that tangent into sine and cosine, because I don't have any formulas involving tangent. So that would be sine t over cosine t over 2t. Now I can move that 2t up a level because it's the same as multiplying by 1 over 2t. So that's the limit as t approaches 0 of sine t over 2t cosine t. Now let's see if we can break this apart so that we can utilize these formulas. So I'm going to have the limit as t approaches 0 of 1/2 times sine t over t times 1 over cosine t. So is this the exact same thing as this? Well, multiply it out and you'll see that it is. So now we are where we can take the limit. So the limit of a constant is the constant. The limit of sine t over t is 1. And if we plug a 0 in here, the cosine of 0 is 1. So times 1 over 1. So that's 1/2 times 1, which is 1/2. All right. I love it. So we're just breaking the equation up so that we can use these identities. All right. Number 5. I've got the limit as x approaches 0 of 2x plus 1 minus cosine x over 3x. All right. See, we've got a 1 minus cosine x. I'll bet you I need to break this problem up so that it looks something like that, so that this is involved. So I'm going to try it this way. The limit as x approaches 0 of 2x over 3x plus 1 minus cosine x over 3x. Okay, so now it's the exact same thing. I just split it apart. We have a common denominator here. This is the exact same thing as this. So that's 2x over 3x, right? It's just 2/3. Now, what could I do here? How about I factor out a 1/3? Is that the same thing? 1/3 times 1 minus cosine x over x is this? It is indeed. And so now we have 2/3 plus 1/3 times, what's the limit of 1 minus cosine x over x? It's 0. So that's 2/3 plus 0, which is 2/3. So if you didn't get that one, don't worry about it. Just try to learn from me working the problem. I seem to, every year, I'm asked to work that problem. So that one typically gives my students a little trouble. But that's good. It's much better to have a little trouble on the homework than the test, right? Okay, and then number 6. We want to take the limit as x approaches 0 of x over cotangent x. Okay, I would like to change that cotangent into cosine over sine, right? So that's x over cosine x over sine x. And now we can move that sine x up a level, right? So that's the limit as x approaches 0 of x over sine x cosine x. And now I can bust that apart into x over sine x times 1 over cosine x. Exact same thing. These two things are equal, right? That equation, it's the same thing. Well, that's 1 times the cosine of 0 is 1. So 1 times 1. So the answer is 1. All right, and that does it for the test review problems. Now for just a few minutes, I want to talk about the test. So we'll call this, I'm not going to work any more problems. We're just going to talk about all the topics on the test. So let's call this the Chapter 1 Conceptual Review. What do you have to know how to do? Or what should you study? First of all, you need to study the opening notes. That's that first couple of lectures. And terms throughout the notes. So just study the notes, because there are, I don't remember exactly how many, but like 6 to 7 multiple choice and true false type questions. All right, I think they're just worth 2 or 3 points each, but you don't want to get all the math right and then miss 3 or 4 of these, because you won't be happy with that. So just make sure you read the notes, and then those understand the true false questions from the first homework. All right, remember that one that gave students a lot of trouble, but it was the first homework. So make sure if you go back and rewatch those solutions if that gave you trouble. You're going to have to work so the problems of the formal definition of a limit. So we did that on the additional review sheet. That's the epsilon delta problems. Okay, so you should expect at least one of those. Then you have the limit laws. And there's nothing to that. You don't have to memorize a bunch of stuff. Really what we're talking about here is plug-in limits. So that was I believe our second homework. Make sure you plug it in before you do a lot of extra work, because I'm going to throw at least one plug-in limit on there. All right. So I believe that would be all of maybe section 1.2 or 1.3. But then we got into the meat, I think, of this chapter, dealing with indeterminate forms. So that's where when you plug it in, you get 0 over 0, and it needs more work, right? And that is the bulk of this test. There's more questions about indeterminate forms than any other subject. So what kind of things did we have to do? We had to factor and cancel. And you might even have to factor cubes, right? The sum or difference of two perfect cubes. So know that formula. Compound fractions, where you had to put some fractions together, find a common denominator, and then clean it all up. The rationalization technique. Well, that is when you have to multiply by that clever version of 1 using the conjugate. So that's when you have a radical. And then the trigonometric limits. And that's where we just did several of those, right? Those identities. So really not hard. You really only have to memorize the sine and the cosine. You can remember the rest of them. This is the bulk of the test. I mean, this is probably, these 4 things probably come close to half of the test in terms of points. So just make sure that you're well practiced on those. Okay, so pause the video if you need to, and we'll keep going. We did one-sided limits. I don't think you will find the questions about the one-sided limits confusing on the test. I worded those. And really, on one-sided limits, it's the same. You do the same. It's the same technique. Unless you have an absolute value function or a piecewise function. Then we had to use the small positive, small negative, that kind of thing. And we actually did a bunch of those on the test review as well. So, you know, unless you get, if you get it, that you're dealing with it when you have a non-zero, you have absolute value or piecewise, and you're going to have to use the small. Also, if you have non-zero over 0, you're going to end up with, you know, having to do that small positive or small negative thing. Okay. But just to make sure, you know, you look over all those problems that we did for that. Continuity and discontinuity. So, unlike the book, discontinuity, I only want to know where's the function discontinuous. I don't need to know the interval where it's continuous. So you have removable discontinuities. That's when you end up having a 0 over 0 situation, and the discontinuity cancels out. That means it's a hole. And then the non-removable discontinuities. Okay, that's where you end up with a non-zero over 0 form. And that's a, you have a break in the function, like with a piecewise function. Break or a jump or a vertical asymptote. Okay. And then we did some infinite limits. And that's just the section on dealing with vertical asymptotes. So where's the denominator 0? Does it cancel? Does it not cancel out? If it doesn't cancel, it's a vertical asymptote. So, and then again, vertical asymptotes occur where denominator equals 0, but doesn't cancel out. All right, and that's pretty much the whole chapter. All right, I want to erase all that. The historical average on this test over many, many years is 87.7. So I would say that it's a test of medium difficulty. So if your grade starts with an 8, you're in pretty good shape. If it starts with below an 8, then you're going to have to up your game on the next test. The next test, Chapter 2 test, is of similar difficulty. Its average is also 87 point something. And then the test after that has a much higher average. It has an A average. Okay? So that does it for Chapter 1. Good luck on the test. Rework those problems that gave you trouble. And I will talk to you for the first lecture of Chapter 2.